So as I can see, a lot of our friends just join us, and nice to hear and see you, Simeon and Livu. It's very good that you join us, our webinar. And today we will talk about LiDAR survey for power lines. And I think it's very important task, and we will talk about it later. So you are free to ask any questions. And then our friend and our partner from Geocentre company from Čakovec will show today how to process data, how to capture LiDAR data. And I think it's a very good idea that we invite these guys from Geocentre to show us how to capture real data, which were, and they made it during their real projects. So you can see all steps of data processing, and you can evaluate results of LiDAR surveys. It's a very good idea. Hello, Victor.
Hello, Victor.
Hi, can you hear me?
Yeah.
Yes.
Perfectly.
Okay, great.
Super. Right now, we are ready to start a webinar about power line survey. And just a short introduction before we start that today we will try to show you real data processing. And Victor is a member of very good team in Croatia, Geocentre company, which has a lot of knowledges of LiDAR survey, photogrammetry survey, geodesies. I know they use a lot of type of equipment like terrestrial LiDAR scanning, like mobile LiDAR scanning, like photogrammetry. And they have very good knowledge and very wide experience of using of such systems. And this is why we invite Victor to show real data sets from his projects, which they captured with TOPODRONE LiDAR systems. Before we start our presentations, I would like to ask, for which application do you use survey equipment? And if you use drones, do you use it for photogrammetry or for LiDAR survey? And what type of survey are you doing usually? Could you write some messages that will help us maybe to make better presentation for you?
For example, I'm using Phantom 4 Pro PPK. I'm flying with UGCS Pro in the AGL with a GSD2, and I'm using the Lunar Mission Planning, for example. Or yeah. I'm just using the DJI Pilot with the MSL.
Okay, so
Phantom.
Yeah, thank you for your notice. Today, we would like to show you the difference between photogrammetry survey and LiDAR survey in application of power line surveys. And you know that it is very difficult to make power line survey with photogrammetry. First of all, you need to fly with a double grid mission. You can point camera in a certain angle to capture power lines. And in order to reconstruct power lines with photogrammetry, it's very complicated task, and it depends on the angle of sunlight, it depends on angle of acquisition, and sometimes it's not possible to capture power lines, especially wires. And with LiDAR equipment, you will definitely receive reflection from power lines, and you will definitely receive very good data sets. Right now it's 2 o'clock, and we will start our presentation. And first of all, I will make a short introduction about TOPODRONE products, about LiDAR products which we offer to clients. And after that, I will ask Victor to show real data processing from mission planning to GNSS data post-processing together with IMU to get precise trajectory. After that, he will generate point cloud. After that, he will make point cloud classification. As a result, you will see how easy and how fast you can get vector layers of power wires and how accurate it can be. So I will start my presentation, and if you have any questions, feel free to ask any questions and to write any questions to me, and Alexander will read these questions and I will answer it during my presentation. Okay, so let me start. Yeah, and my suggestion that after both presentations, maybe we can switch on voice messages for our members. we can answer questions in real time. It's a very good idea. As you know, the Topodrone company provides different kind of equipment which can be installed on any kind of DJI drones to make precise photogrammetric survey, to get very detailed and very accurate point cloud, which can be used for mapping. And several years ago, we designed our solution for LiDAR survey. And a LiDAR survey, as you know, is more stable in case of, you can use LiDAR in any light conditions. You can use LiDAR even at night, and LiDAR penetrates forest, penetrates dense vegetation in a very good way. And of course, LiDAR survey is the next step of surveying, of technology of surveying. And before, when we designed our LiDAR solution, we decided that we need to create something very affordable. And this is why we created different kind of LiDAR equipment, but we are still supporting our PPK solutions, which can be installed on any kind of photogrammetric drones, like Phantom 4 Pro, Mavic Mini 2, DJI Air 2S, or Mavic 2 Pro. And you are still able to order this equipment from us. And this equipment converts consumer drones to high precision survey drones. And the main advantages of our equipment that all our GNSS receiver, which is produced by us, are installed on the drone, and all this solution has a connection, have a connection inside of DJI system. As a result, you will capture photo events very precisely, and as a result, you will get a very precise photogrammetry model. And all our systems work in a PPK mode, in post-processing kinematic mode, which allows you to fly even in hard-to-reach areas without any connection to GSM network, without connection between drone and base station. As a result, you will get very stable solution for real survey works, especially in hard-to-reach areas and difficult areas and so on. And our newest solution for photogrammetry surveys is Mavic Air 2S, where we install PPK equipment. We install GNSS receiver on the board of the drone, and we connect this GNSS receiver to the DJI system to capture photo events very precisely. And within 1 or 2 weeks, we will make a first webinar about photogrammetry data processing captured by DJI Air 2S drone. With additional install our equipment, and you will see how accurate can be models. And I think it is the most affordable survey drone right now at the market. It has very affordable price and can be combined with a different type of processing software like Pix4D, like Agisoft, or with 3D survey. And with 3D survey, we have a special offer, and you will get 3D survey together, 3D survey photogrammetric software together with our drone, and you will test it, and you will see how detailed point cloud can be with using of affordable hardware and affordable software. Of course, we are working with enterprise solutions, and our latest design in case of photogrammetry enterprise solution is it's a camera with a 61 megapixel resolution, which can be installed together with the LiDAR. And you will capture high precision LiDAR data together with photogrammetry data, and you can colorize point cloud, and you can use this high resolution images, especially for power line monitoring. The main advantage of this system that you can fly with high resolution camera and with the LiDAR at the same time over the power lines, and you will capture three-dimensional model of wires, three-dimensional model of poles, of towers, and at the same time you will get images, and you can understand what has happened with the power lines, and you can visually analyze real conditions of all objects of power structure. And today, by the way, Victor will show how to use our LiDAR system together with P1 camera, which is installed on the drone at the same time, how it can be used for real power line monitoring. Additionally, we have a solution how to install multispectral camera together with the LiDAR. And in this case, and as you can see, multi-spectral camera is installed on the gimbal, and you can change angle of acquisition. It's totally the same, like you can change angle of acquisition of 61 megapixel camera. And in this case, you can fly just with the 2 or 3 lines along power line, and you will capture images from nadir, and you will capture images from oblique flights, and you will get more information about power lines as well. And at the same time, you can use LiDAR installed on the drone. In this case, you will get very detailed point cloud, and you don't need to spend a lot of time for photogrammetry data processing to generate three-dimensional model. what you need just to get three-dimensional model from LiDAR, and you need to capture photos even from multispectral camera, and you can analyze some structure in different multispectral diapasons for your future monitoring of power lines. If we're talking about our LiDAR solutions, right now we have several models, starting from entry-level solution, which is based on LiVox Avio sensor, which has very affordable price, a little bit noisy point cloud. It's due to the sensor, but inside of this LiDAR, we use the same IMU, the same technology like in our advanced systems. And as a result, you will get more stable point cloud, and you don't need to spend a lot of time for calibration like you use for DJI L1. You know that DJI L1 LiDAR should be calibrated every 100 seconds. It means if you fly with 5 meters per second speed, the drone will stop and start to make special calibration movement during the flight just to calibrate IMU, because inside of N1 LiDAR we have less precision IMU. And inside of our solution based on LiVox sensor, we have high precision Honeywell IMU, which provides you very stable results, even installed on the drone or even installed on the backpack or on the car. And of course, we provide a lot of LiDAR systems which are based on Velodyne sensors. I would say that right now, Velodyne sensors, it's the major Velodyne, it's a major player on the LiDAR market. And right now, we have three models. First of all, Topodrone LiDAR 100, which is based on PAC sensor, but it is not original PAC sensor. It's specially adopted sensor for mapping. It's a high-res model of this sensor. It has different angles of acquisition. As a result, it has 16 lasers, but angles of this laser is less, and as a result, you will get more detailed point cloud with less noise. And of course, we provide very efficient solution. It's a Topodrone LiDAR 200, which is based on Ultra PAC sensor, which has very good working range. You can fly from 16 meters altitude up to 150 meters altitude, and you will get very detailed and accurate point cloud. And Victor today will show in reality how they use this Topodrone LiDAR 200 system for real measurement of power lines. And of course, what I would like to draw your attention, it's our new solution, which is based on HDL Velodyne sensor, which has perfectly calibrated system inside, factory calibrated Velodyne sensor with 32 lasers. Inside there is high precision IMU from Honeywell. As a result, you will get a perfect point cloud with less level of the minimum level of noise which I saw from LiDAR, from drone-based LiDARs. And it has very affordable solution for such kind of equipment. And right now, I would like to show some real examples, some real projects, how we use our LiDAR system for power line survey. Here in Switzerland, we made several projects. And usually our power lines here in Switzerland, they are located in the mountains, and we need to make a terrain following mode to fly with the LiDAR. And for these projects, for example, we use Topodrone 100 LiDAR, which has working range on 70 meters, but it's totally enough. If you fly with the terrain following mode, you will capture power lines even in a very high slopes of terrain. And the point cloud from LiDAR 100 is amazing. You can definitely recognize all power lines, all wires, and additionally, you can easily, and the point cloud is very detailed, as you can see. And additionally, you can easily extract the terrain from even in a forest, and you can easily extract all power lines. So, but my aim not to show today all data processing, because Victor will show it. And it's amazing that within 30 minutes, I think we will get all data sets and vectorize all data sets. But in reality, when we made this project, it was just last year, and we just fly over these power lines. And after that, we were sitting for lunch in a restaurant. And the client said, "Why are you so focused? What are you doing?" I said, "I already processed your data set. After just 20 minutes after the flight, I already processed data set during the lunch." And I got this point cloud, and it's a major benefit of LiDAR that you don't need to spend hours or days to generate point cloud. You can do it even in the field, and you can analyze all your data in the field, and you can deliver your products to the client within several days after flying. Really, even at the end of this day, it's a reality. And another example of powerline survey, it's using of LiDAR 100 HDL, which were based on Matrix 300, and it can be combined with a high-resolution camera as well. But camera will be installed on the back of the LiDAR, and I can show you, and you can read our article in our website, in our blog, how we use this LiDAR and how we install the camera with 61 megapixel as well. But as a result, when we made a survey with LiDAR 100 HDL, we were impressed by outstanding quality of the point cloud. And as you can see, this point cloud is very clear and very detailed due to the 32 lasers, which has different angles of acquisition. And as a result, you will have very detailed point cloud from different angles of view. It's amazing, and it is the best advantage in comparison with solid LiDARs. And of course, you can easily classify this point cloud. I don't like to show how it was made, but Victor, I think, will make it today. But you can easily classify power lines. You can easily classify overhead cables, insulators, transmission lights, towers, vegetation, terrain. You can easily extract terrain from the point cloud. For example, like this, you just extract vegetation, just leave only terrain. And after that, you can vectorize data set. It can be done like this one. Within 1 or 2 minutes, you will get vectorized power lines and wires. So this is the advantage of using of LiDAR technology. But it's my short introduction, what you can do with the LiDAR and what kind of equipment we offer. And of course, we offer any kind of support, any kind of training. And of course, last year, at the end of last year, we met together with Victor in their office in Čakovec, and we provide training for them. And after that, they made outstanding projects, very impressive projects, which I would like to, I invite Victor to share these results.
Thank you, Maxim, for this introduction. Hi, everyone. I would like to share my screen so you could see the presentation I have prepared. So hi, everyone. My name is Victor, and I come from Croatia, from company Geocentre. Geocentre is a company that is dealing, well, we are mainly distributors for surveying equipment and instruments, and also software solutions. And we've been on the market for 30 years, of which we have 8 years experience with UAV solutions and about 3 years of experience with UAV-based LiDAR solutions. And last year, we started distributing and making educations for people using our clients using the TOPODRONE LiDAR solution. Geocentre as a company is quite established on Croatian market, since we are the first one to introduce to the Croatian and Slovenian market survey-grade GNSS receivers, RTK fixed-wing UAVs, also LiDAR SLAM mobile systems, and UAV-based LiDAR solutions. So we can definitely say that we have a lot of experiences with testing the technology, and our main goal is to see how to use that technology for our clients and to make it fit their needs. So the same thing we did with the LiDAR solutions. And before we showed it to our clients, or let me say, when we try to show the client the equipment, then we do different projects with them. So I will show you a few different LiDAR projects that we did in order to show to the clients what is possible. For example, this is one mountain where we use the LiDAR in order to penetrate the vegetation to get the ground, where we use the terrain following feature of the M300 in order to get the drone up to the highest point. And the difference is about 250 meters from the lowest to the highest point of this mountain. This was quite challenging project. The next project was also the project for making the situation on for surveyor to see how he can make the mapping of the terrain with the forest. And as you can see, it is really easily possible to remove the vegetation and to get the ground from the LiDAR data. So now, after a few of these projects, one of our clients, who is a major Croatian powerline company, came to us and they asked us, okay, can we help them to find a solution for them, because they need to measure towers, they need to measure power lines, they want to get the ground, and also they need to see surroundings, let's say obstructions like vegetations, buildings and stuff like that. And also they needed to produce an orthophoto image of the power line area. And as it usually is, they have the most of the power lines, at least in Croatia and around the Croatia, are in the places that are hard to reach, that are with the different heights you have on the mountains and everything. So it was really, really important for them to be able to use the terrain following feature. So at that moment, they looked at different solutions, but together with Maxime, we were able to show them and provide them the right solution for them. So the equipment they decided to use was DJI M300 UAV, together with Topodrone LiDAR 200 Ultra and DJI Zenmuse P1 camera. All of this is then combined with Topcon Hyper VR GNSS receiver as a GNSS base, because, as you know, to get better accuracy, you would use PPK post processing. So you can use basically any GNSS receiver, but since they're our client, they bought from us the Topcon receiver, so they used it. So to look quickly, what are the features or specifications of Topodrone LiDAR 200 Ultra? It has accuracy, special accuracy, as you can see, 3 to 5 centimeters. The most important thing is the range, which is up to 200 meters. And also it supports 2 returns, which is quite important. And it has high accuracy GNSS receiver inside, and also very accurate and stable IMU. Why then our client decided to use this LiDAR solution? Well, the range of 200 meters was very important for them, because some of the towers can get as high as 70, 80, or even 100 meters. So in order to fly those towers, those power lines, and in order to get the ground below them, you have to have a good enough range. So the range of 200 meters means that you can fly, as Maxime said, around 150 meters, which is really good enough to get power lines, towers, and also the ground below them. Also very important for them, since there are a lot of, every power line is really long. So you do not want to have to calibrate every now and then your LiDAR IMU. It is very important to have accurate and stable IMU where you do calibration at the beginning, and that's it. Maybe if you want, you can do the calibration at the end just before you land, but it's not really necessary. So you don't lose your battery to do the calibration of IMU, and then you can survey much longer power lines with one battery pack. Also, it was very important for us to have a PPK solution for processing of Zenmuse P1 camera positions, which was provided to the client with Topo LiDAR software or Topodrone post-processing software, because a lot of power lines are, as I said, in the hard-to-reach areas where you maybe do not have mobile signal and you're not able to use RTK solutions all of the time. So PPK is definitely a must-have for such application. And one of the most important, definitely most important feature of this solution is that it is really affordable. It is one of the best, let's say, solutions you can get for that price on the market currently. So the workflow, I will now go through the workflow that you have to do when you do this kind of survey, and then I will show you the most of the workflow. So the first thing you have to do is you have to do the flight planning. We decided to use UGCS because it has a lot of features, a lot of professional abilities to control every single part of your flight. Also, it provides us with already imported model of terrain, which you can use for terrain following. Then you would, after you calibrate it, you would take off, you would do an IMU calibration. You can do this manually, or you can do it through the UGCS software. You can do the figure 8 inside of the software, or as I said, you can do it manually in the air. Then you start the planned mission, and after you start the automatic planned mission, the drone goes and then it collects the data along the power line. After the drone is done, you can land it, and the drone has the built-in USB-C connector to which you just plug in your external hard drive or your USB stick. Topo LiDAR automatically transfers the LiDAR data to your USB stick, and you're done with your field work. This usually takes not a long time, maybe a minute or two, because it depends on the size of your LiDAR survey. Later on, you use that data to calculate the trajectory inside TOPODRONE post-processing software. Then you use that trajectory and to generate point cloud inside, again, TOPODRONE post-processing software. And then we can use this point cloud and trajectory data to go to the LiDAR 360 software to do the strip alignment if there is need, because if you do a pre-calibration of your IMU and of your LiDAR solution, most of the times you can use those pre-calibrated parameters, so there wouldn't be a need for strip alignment. And in the end, you would use that point cloud to do a classification and measurement within the powerline software. And this is what we will show you, what I will try to show you today. So the first part would be flight planning within UGCS. I will show you now the video, which will demonstrate how it is done. So the first thing to do, you have to create a new mission. You give the mission some name, and then you set up some parameters. You choose the UAV you're going to be using. You choose the action if your drone loses signal, and then you can start planning. So the first thing to do is to put the first waypoint. We usually put the first waypoint just above the drone where we're positioned at, and we would put the height of that first waypoint to be around the height of the rest of the mission. Then it depends which version of the UGCS are you using. Here we were using the version which does not the Enterprise but the Pro version, which has the corridor mapping feature but does not have the unlocked LiDAR corridor mapping feature. But nevertheless, we can use this. So now you would draw a line of your corridor. The best practice is to put every breakpoint on the position of your tower of your power line, and then you would adjust the parameters of the corridor mapping. So we would use stop and turn type method. Then we would define the width of the corridor, and we would define the flight speed. Here we used 10 meters per second. It's very fast, but this is from our experience the speed from which you can get enough of data, and you can also maximize the flight time of your batteries. But it is important to say that if the conditions outside are cold, then you should maybe use, if it's below the zero, you should maybe go with flight speed of 5 meters per second, just to be safe because of your drone. Also, now you can put the ground resolution, which will define the height of your flight. Since this is primarily photogrammetry corridor, Mapping, you have to define it through the GSD, but that's not a problem. If you put about 1.9 centimeters, then you will your flight altitude would be around 70 meters above ground level, which means that the reference point is your takeoff point. And at the end, you would again put the last waypoint, so the drone would come back to you when it is done with corridor mission, and then you would take the drone and land it yourself manually. As you can see here, we used only 2 lines for power line surveying. From our experience, that's enough. There is no need to have 4 lines. Only 2 lines is enough, 1 in each direction. But this is only if you're doing LiDAR surveying. If you want to do LiDAR and photogrammetry surveying, we would definitely suggest for you to use 4 lines because of the photogrammetry in order to get better results. But from our, you can definitely, with this solution, TOPODRONE has the holder for the LiDAR, which enables you to use the LiDAR and P1 camera at the same time. But from our experience, it is much faster to do the LiDAR survey and then after that to do separately the photogrammetry survey, but it depends on the case. And yes, after that, you're done. You can upload the mission to your controller. After the upload, you can click the upload button. The mission is uploaded to your controller, and then you can take off with your drone. You can do the figure 8 manually, and you click automatic mode, which will then start the mission, and your drone will go and survey. Now, after this, as I said, you would land the drone. You would put your USB stick or external hard drive in the USB-C connector, and then you would use that data to do the post-processing, which I will now show. So the first thing I will show is post-processing using TOPODRONE post-processing software. We will first do the trajectory post-processing, and then later we will do the point cloud generation. I can show you in LiDAR 360 how to check if the strip alignment is okay, but since we have calibrated this LiDAR, I think there won't be need to do the strip alignment. And at the end, I will show you how to do point cloud classifications and power lines measurement in the powerline software. So I think we can start. At the beginning, as I said, you get from your LiDAR, you download the data, and your data is downloaded in archive format, zip archive. And as you can see, it is named by the date and the time that it was created. So the first thing to do is to extract this archive, which I will do. And inside of that, there will be the data needed for the post-processing. So as you can see, you have the log, you have GNSS raw data, you have IMU raw data, and also you have your LiDAR raw data. And all of this we will use in order to get the point cloud using TOPODRONE post-processing software. So here, TOPODRONE post-processing software, it allows us to do many different things. The most important things today we will use are static post-processing. We will use LiDAR post-processing and LiDAR cloud generation. Because we are doing a PPK processing for the trajectory, we like to use our own base. We have the easiest thing for us is to use a magnetic mount, and then we put the GNSS on the roof of our car. And then the first thing to do is to get the coordinates of our GNSS receiver that we will be using as a base for LiDAR trajectory post-processing. So this is quite a good feature because you have everything within one software. You can use this static post-processing where you would select your rover GNSS file, you would select your navigation file, you can automatically download your precise ephemeris, and you can also select your base station file from, let's say, your course network or something. This part I will not show because it's straightforward, and I have already processed my base station, and I have recorded the accurate position from this into the RINEX data. So the first part to do then is to do the LiDAR post-processing to post-process the trajectory. The software is leading us with first, second, and third thing to do. So the first thing is to select the drone GNSS file. I will select it from my folder. So here it is, the extracted folder, and you can select only this GNSS file. I will say select open. Then the software will ask me to select or write in the drone model, or to write in the offsets for the holder. Since we are using the TOPODRONE solution, it already has the offsets saved into the database. So I just have to choose my LiDAR 200 on DJI M300 RTK. And here you can see it just automatically fills the offset. And the third part is to select our base station. I will just choose my base station, RINEX data, which, okay, I have to choose the navigation file, okay. And as you can see, I have here the coordinates, which are the precise coordinates determined by static post-processing, which were then saved into the RINEX file. And the TOPODRONE software recognized that and imported those coordinates. Now that I have everything imported, it's just a matter of clicking the start. So the software requires now internet connection just to upload the data to the server, which will make the post-processing really fast. As you can see, it has already uploaded, and now the data will be post-processed, and then it will be downloaded back to my computer. This is very good system because you don't have to have any special software or any powerful machine in order to do this processing, because it is done on the server, and you just get the data really, really fast anywhere in the world. So now you can see software says it's waiting for the server, and then it will download the data for us, and then we will use that trajectory data later to post-process to generate the point cloud from the LiDAR.
Victor, can I ask you some questions before?
Yeah, of course.
Have you ever used another one kind of software for post-processing? For example, Inertial Explorer or something like that?
I have not used the Inertial Explorer. I did use the Applanix UAV. So, yeah, post-processing.
And
yes.
how long does it take to prepare everything for post-processing in general?
Yeah, well, in that software, it's a bit complicated because you have to know everything, and you have to take in consideration a lot of things and import everything, and it's quite complicated, let's say.
Yeah,
at least when I was doing it, it took me for about maybe 20 to 30 minutes to post-process the trajectory, because it was not automated. And
yes, this is why before LiDAR data processing, it was look like a rocket science. So you need to know everything. But right now, but in reality, LiDAR data processing, it's few times easier than photogrammetry data processing.
Yeah, definitely.
But in order to get such results like you receive right now, you need to follow several steps, and you need to follow instructions and to get a training. And this is why I like Victor, because he made right now a very good presentation, and I really enjoy it.
Okay.
Thank you. Okay, so
yeah.
let's continue. Thank you.
Yeah. Okay. So as you saw while I was talking with Maxime, we got our trajectory back, and yeah, as we mentioned before, it was quite difficult to get to this point because you needed to know a lot of things. You needed to tweak a lot of parameters within the software. You needed to, it was much more complicated than this. We could say this is what, 1, 2, 3, 4 click solution. So it's really simple. And the software is done. We get our track visualized on our screen, and we can now close this, and we can move to the second part if we check the presentation, which is point cloud generation. So let's do that. We will go to the tab LiDAR Cloud Generation. And here we have number 1 and number 2. First, drone file, we have to choose the LiDAR file, which is again in our folder from the LiDAR sensor. We choose the PSAP file, and then we have to choose the track file, which is the track that was just created from this processing of the trajectory. We open it. In the second part, we have this drop-down menu where we can save our, you can see, we can save any, if we have maybe multiple LiDARs available, we can save the calibration parameters. So I have here saved calibration parameters for our LiDAR that we are now using. And this, after calibration, helps us to avoid the step of strip alignment. And now the third part would be to choose the coordinate system in which we want to generate our point cloud. So the first part, I want to do it in the projection. And in Croatia, we use this projection, HDRS 96. Transverse Mercator projection, and also I will choose the Croatian G8 model in order for the heights to be accurate as I want it. Also, important step here is to trim my trajectory. What this does is, as you can see, this is my trajectory, and here at the start we did the figure 8, and this part where LiDAR went to the beginning of the power line and the part where the LiDAR went back to the home point, we do not need the point cloud from this part, so we will exclude that. Very easy, we select the first point of the track, we select the last point of the track that we want to use, and in the red we can see this part will be excluded. Also, we can split the lines just by selecting this and saying accept. Now the software will automatically recognize first and the second line of the LiDAR survey, as you can see, and we can select which line we want to choose. In this case, we want to choose both lines for point cloud generation. Now, when I click OK, I can now click Start, and the software will start generating point cloud from those two lines. Okay, now I can see that here in this viewer, it shows me in real time how my point cloud is being generated. So this yellow lines show the trajectory the drone was moving. And here you can see the red point, which represents the drone or the LiDAR, which is moving and is collecting the points. This step is, well, it depends. If you have really large survey, it may take maybe 5-6 minutes, which is nothing. If you compare this to, let's say, photogrammetry, this would take 3 or 5 times more than this. So now I just wait for the point cloud to be generated. If maybe we have some questions, we can use this time to answer some question.
Super. What I would like to show right now, as you said, you use stop and turn type of trajectory. It means that on a turning point of trajectory, drone will stop and then it will fly again. And now during point cloud generation in real time, we can see when a drone stops on the turning points. In this case, in order to, and when drone stops on the turning points, it's make like this one. And like this one point was a stop point. And in this case, sometimes IMU is not capable to catch all movements of the drone because of the fast moving. In this case, in the future, it's better to use adaptive banking part of trajectory. So I saw it during presentation. I don't like to disturb because it was perfect. But in this case, don't stop, and you will get more precise point cloud in this area. So as smoother you fly, is better point cloud. Yeah, so,
definitely. But from our experience, we would cut this part, the beginning and the end out, where the IMU had the sudden movement, because as you can see, these lines are really next to each other, and then the UGCS is aware that the drone cannot make the adaptive turn, and it will not allow you just for the power line survey to use the adaptive bank turn every time. So from our experience, for these lines really close to each other for the power lines, we noticed that it's better to use that and then to cut off the wrong parts.
Yeah. And you can see that while we are discussing, point cloud has been generated. So right now it's more than several hundred billion of points right now.
And the point cloud is now being generated, and as you can see down here, it is being saved, and there it's saved. And I can close this window.
What I would like to add, what we have more in the software, we have a batch processing. It's very efficient function as well. So if you make several flights per day from the same base station or with the same LiDAR system, you can add the data processing here, and you can add additional flights to generate point cloud in automatic mode. In this case, if you for long line survey, when you make 30 kilometers per day or 50 kilometers per day, it's really easy to survey 30 or 50 kilometers per day with a flight speed of 10 meters per second. Really. In this case, you will have several flights, and in this case, you can use batch processing. Just to add several flights, and after 15 minutes you will get all your flight process. Okay, thank you. I just try to add more, but okay, let's go.
Okay, and as you can see here, from the start and end time from the trajectory, so it's 12:03 and 12:07. So it took us only 4 minutes to do the survey of this power lines, and you will see now that we have the point cloud. It is part of the power line with 4 towers, so it's really fast on the field to collect the data. So now that I'm done in this software, Maxim, if you have nothing to add, can we move to the LiDAR 360?
Yes, everything is perfect, and I just want to say some words while point cloud has been generating.
Okay. I just wanted to check if I maybe forgot something.
No, it's perfect.
Okay, so in LiDAR 360, I will now import the point cloud. I can do that with right click on the point cloud and just import the data. And now if I go to the here to the folder, I can see that it has created the LAS file with the point cloud. When I click open, it will now take maybe a minute or two in order just to import this point cloud and to convert it to its own format. It really works quite fast. I was really surprised by the software. It really is it's stable, and it uses your resources optimally. So currently I'm running this on my laptop, and as you can see, it's really moving really fast. The Topodrone software works quite well, and this works also without a problem. So after we import the data, we will take a look at the alignment of our strips or of our passes in 2 different directions. And if needed, we can then improve accuracy of our point cloud, but that depends if you have good calibration. Most of the time, if you have good calibration, there is no need to be stressed about this. So now I see, okay, we are at 85%. The point cloud will be imported quite fast. And then we can proceed to strip.
Okay, right now we have some problems with internet connection from Victor.
Victor's back here.
Okay.
Yeah, Victor, we just lost
10 seconds
from your presentation. Yes.
Okay, sorry.
Yes.
Can you see everything now? Okay.
Yes, now it's okay.
Yes, super.
Okay,
super.
great. Okay, so I can see now my point cloud that was just generated, and I can see it in gray intensity view, but I will change the view to elevation view, and I will turn on the EDL filter just in order to better see the point cloud. Now, as we can see here, we have the power line. Yeah, you can see here the power line, and also you can see everything. So the point cloud is really nice. We have all the power lines. We have we have the towers really nicely visible. We have the ground. Also, we have the vegetation. So I would say I'm really satisfied with these results. And as you can see, the power lines are really dense with points, so it's really high detail. Even though we were flying with 10 meters per second, we really got very good results.
Victor,
So now
one question. Could
yeah.
you move a little bit point cloud on to look at the right side of your point cloud? There is a small. I just saw it. There is a very small power line in a village close to the buildings. I think it's a power on another one side of close to the buildings.
This one.
Yes. Oh, yeah. It's is it a power line or what is it?
I am not sure if it is a power line. I would say
maybe it's a gas pipeline.
Yes, it could be. I'm to be honest, I'm not sure, because when we were flying, we stood right here next to this pole. So I was not able to. I wasn't walking here, so I'm not sure what was it.
But it shows us possibility to capture data even on a very low altitude, very small size of the data. It's a great advantage of LiDAR 200. It has 32 lasers, which has different angles of acquisition, and they have different angles of survey. As a result, you will get very detailed point cloud, even on a long distance from the LiDAR, which is not possible from other solutions.
Yeah.
Okay. Sorry for interruption, but it was very beautiful example how it looks like close to the buildings. And what is the size of the survey? You fly two lines, and what is
what is the length?
Not length. What is the corridor of your survey?
So the width. It is the 70 meters. 70 meters, I believe. And as you can see, the length is 1 kilometer. So for 1 kilometer in 4 minutes, and we can see now. 1 kilometer.
1 kilometer. But
the width. It is 160 meters with just 2 lines.
Yes, 160 meters from this altitude. But if you fly higher,
you get even more.
You will get up to 350 meters if you fly from 120 meters altitude.
This flight was done from about 55 meters. So if you go higher, then definitely you will get better coverage. So now what I would do is I would go in pre-processing, and I would use the calibration tab for bore site. I would open the trajectory file. I have to select the workspace first. Okay. So this is my trajectory file. I would open it. This trajectory file was generated by the software. So now I just have to tell the software, the LiDAR 360, what is the format of this trajectory file. Now that I say what is what in this file, I can select my coordinate system, which again was creation coordinate system, and I will say apply. Okay. I will just change the view to intensity in order for you to better see these 2 green lines, which represent the trajectory of the drone, of the LiDAR. And I can use the draw polygon feature to split those lines once again. There. Okay. Okay, so I split them into the yellow and the blue one. I will do the split trajectory, and now I can cut the point cloud based on those trajectory. What this does is the software looks at each point, and if the point was made from first or from the second part of the trajectory, and then it splits them in order for us to be able to see if the alignment of the two strips were done accurately. So I will just wait a little bit for this progress bar to go to 100. It should go quite fast now. Well, currently my laptop is running the Zoom meeting, so it's maybe a bit slower than usual. But okay, we are now at 99%. I think that's really fast enough. Yeah, it asked me, do I want to add the splitted point clouds to my project? And now you can see it has created 2 point clouds from one. If I match those point clouds with my lines, you can see that they are overlapping. So just in order for me to check if everything is okay, I can make profile section on one part of this trajectory. Let me just set the profile to be 1 decimeter. Yeah, okay. And now if I do a profile, I can see that there is really, really good alignment with my data. As you can see, the yellow and the red part of the point cloud are really nicely fitted together. If that were not the case, I would then continue with strip alignment in this software, using here this button calibration. But I can say that I'm satisfied with this. And then I can continue to the powerline software to show you how to extract the data from the point cloud. So inside the powerline software, you can see basically it's really similar idea of the interface as the LiDAR 360. I can start by adding my point cloud data, right click, import data. And now I will use my, I will use my powerline. Okay, point cloud. Okay, and now while importing, the software asks me in which directory I want to save all of the results. So I will here create a new directory, which I will call, let's say, powerline. And I want everything to be saved inside of this software. Also, it asks me what is the projection, the coordinate system, and what is the voltage level of this power line. You have here classification and detection parameters, which can be used in order to tell to the software what are the distances and tolerances. You can select the XML, which comes with your software installation, and you can then edit those values if you want here at the beginning. But most of the times I'm satisfied with the default values, so I will click OK. Now I can change my view to be displayed by height again, and I will turn on the EDL filter. And as you can see here, we have the same point cloud again inside of the LiDAR 360 software. So the first thing to do here is to tell our software where the towers are positioned. The software is semi-automatic or guided automatic. When guided, it can do automatic detection. The first step is to mark all of the towers, the height of the towers, in order for the software to easily recognize. So I would go here in the tab Point Cloud Real-Time Condition. I would click Mark Tower, and now I can click on the top of each tower just to mark it. Now you can see this tower is marked with number 1. Then I would go to the second tower. I would just click on the top of it. It's tower number 2, and so on for every tower you have. You can see it's really quite fast to do this. It's no big problem. And now when I do that, in this tab view, I can see tower number 1, number 2, number 3, and number 4. And the software asks me what is the type of this tower. So you have two types. You have the tension tower, which has the insulators like horizontally, and you have the straight line tower, which has their insulators like this one, which are just hanging down. So all of these towers are straight line towers, and I will mark them as such so the software knows. Now that I have done that, I can close this mark tower tool just by pressing again this button, and now my changes are fixed. From now, what I would do is start the automatic classification for this point cloud, which is done through this clip classify function. It allows me to do a classification for multiple things. So here I can set the width of my corridor that I want to be used. And here I can select what else I want to, what I want the software to classify. So I wanted to classify the shield line, the insulators. Also, I wanted to classify buildings, and I wanted to process overlapping area. Now, what I would do is I would press start, and then I would wait for about 5 to 10 minutes for the process to be done. It takes, usually for me on this laptop around 10 minutes for the classification. I will not start it right now just because I don't want to bore you with the waiting of the processing. So I will just import the already classified data. I will go on import, and now I will use this 3-point clouds, which are already classified. Okay, and I can close this original point cloud, remove. So this is how your data would look like after the classification. So as you can see, the software cut off the access point cloud around the power line. And now if we zoom in, we can see that our power lines were correctly classified. So to the left, we can see what each of the color means. So you can see that the shield wire is blue. This is this uppermost wire. Conductor is the orange wires. Our towers are in gray. Yeah. And we have insulators in orange, which really, if we take a look, you can see here we have our orange insulators. Currently, we cannot see the ground because the unclassified points are white and they're hiding the ground. So I will just turn off the unclassified points from the view. Yeah, and now you can see all of the ground along with the power lines, towers, and the buildings. You can see that the LiDAR really did penetrated all of those trees and all of those bushes, and we really did get very good data for our ground. I will turn again on the rest of the classes where you can see now. So here is the so you can see this is very thick forest, and the penetration of the LiDAR was really good. So we got all of the ground. Now the first step we want to do, we would like all of this vegetation and everything to be classified as vegetation. This is done quite simply using classify tools, and we will do classification by height above ground. We will tell to the software to move everything from the never classified class, which has minimal height of 0 above ground, to maximal height, let's say, of 40 meters above the ground classified points, to which class? To the class of low vegetation. And now we will see the software will then automatically classify everything else here as low vegetation. It is important to say that automatic classification works really well, but it is not perfect. It can never be perfect. So you have to be careful and always take a look at your data. Really see if everything is really classified as it should. For example, I think I know for this data sample, yes, if I zoom in here, I can see here this is a structure which should be classified as building, but it isn't. So before moving on, I would like to classify this from low vegetation to the building class. And to do that, it's really simple. I just use the 2D profile tool. And when the tool loads, I make a small profile on that part, and now I can see this is my building from the profile view. I choose this point to be classified to the building class, and now all I have to do is just select those points on my profile view, and as you can see, it's now colored blue since I have just classified it to the building class. As you can see, it's quite simple to do manual corrections of the classification. Also, now what I would like to show you is just to check if all of our towers are classified okay. It's quite nice to use the profile view just to see the towers. So now I will make one section of the tower and I will turn off the numbering point. And as you can see, the tower after classification. So the gray color is the classified tower. The yellow color are the insulators, and the orange color is the conductor. And up here is the shield wire. Also, we can see the ground and the vegetation are down here. I don't know about you, but I'm really satisfied with these results. We can also make one other section along the power line just to see everything. Okay, and yeah, as you can see, the power lines are all here, and all of the towers can be seen classified really well. So I'm quite satisfied with this, so I will close my profile view. And the next thing I will do right now is I will do automatic analysis to check clash detection. If there are any obstructions that may cause the damage to the power line. This is done automatically inside of the software by using this function danger points. So if I now click on this, I just press here start. I can adjust the parameters, but for the showcase purposes, I will just use these default parameters. And now I will click start. This process is really fast. It will now check for every point that may represent some sort of danger to damage the power line, for example, buildings or some trees or any other structure that may cause the damage if wind blows and maybe moves the power lines or for example, this structure. Very good thing in this software is that you can do really a lot of analysis. I will show you this one and maybe a few others, but a lot of these analysis takes some time. For example, as you can see here, you have tree growth and tree fall and tree growth warning analysis. So what the software does, it classifies every tree differently and then analyzes by certain parameters from the time perspective. If your tree grows, let's say 1 meter per year, it can analyze and tell you after 3 years, you will have a tree that may cause collision with your power line. This classification takes about 10 to 15 minutes on my laptop. I will not do that today, but if you're interested, you can definitely ask Maxime to show you the data of the classification. As you can see, this danger point detection goes really fast, and the processing is finished. Okay, so now on my point cloud, you can see all of these red points represent the danger points that may cause collision with my power line. Also here on the right, I have a table which represents every segment of these danger points. and it represents the distance from my power line. I can double click on any of them. Software will zoom in to that point and it will show me, as you can see here, this tree is about 1.7 meters distance from my power line conductor, which can cause damage if power line were to move from wind or something like that. All of this can be checked manually, or you can create a report. For this, I can go and create image, and I can now tell the software to start and to create the image report for this. In order for us not to wait for this, I can show you this part. Just give me 1 second. Yes, I have done this a bit earlier, so it would look something like that. You can create the report, which would be exported automatically to the Word document, in which you have every information about your power line, about your survey, about your classifications. And now you have coordinate positions of every point that is detected to be dangerous. Also, you get this image view, which shows, for example, this tree to be 1.76 meters from the power line. As a danger point, you have coordinates, and now somebody could go out on the field using this data and then, for example, remove this tree, or if it's any other obstacle, you can then do some repair work or damage prevention. The next thing I also mentioned was the tree growth analysis, and I can show you some reports from that, how it would look. I have it, I think, somewhere here on my hard drive. Okay, I won't find it, but nevertheless, if you're interested in that, I can show you later on that. Now I will clear all of these danger points, just to have my point cloud be a little bit more clear, and I will show you how easy it is to vectorize your power lines from your point cloud. So the software, as you can see, automatically classified the point cloud. I will now just remove this from the view. I will remove the low vegetation points just to have more clear view. Oh, sorry. Okay. And now what we can do is try to automatically draw these power lines. I will go into the vector real-time condition tab. I will click on start and the vector editing. And the first thing to do is to note to the software where are the insulators. So the first thing is that I have to know which type of insulator is here, or what is the length of this insulator. If we don't know what is it, we can just check it using the 2D profile. We can make the profile section of our tower, and then we can measure on that profile the length of our isolator. So I will make the section, then I can go to the isolator, then I can select the measure tool, and I can measure the length of the isolator, which I see is about 1.6 meters. So that is the value that I'm going to be using. So now I can just go to the start and vector processing, hang insulators, and here in the software, I will just tell the software that insulators on these power lines are 1.6 meters long. And now it is just the matter of selecting the insulator. So I can just click on the insulator, and as you can see, the software automatically recognizes the insulator and draws it on its place. It's quite easy to do this. For this, you have to do this on every power line pole. Yeah. And as you can see, it's really fast. It's no problem to just click one point on your insulator, show the software which insulators we want vectorized and marked. So here on these 4 towers, it's just a few clicks, and yeah, here I have done that. I can close this tool, and after that I can use the function inside the software to vectorize all of the power lines. Here I have the batch function, which does batch fitting power lines. I just click start, and the function should now draw all of the power lines in my point cloud. Okay. Just a moment. I see here I have marked these two insulators on the wrong spot. So I will just correct this. Okay. Let me fix it. One moment. One moment. Okay. Are all of the other insulators on the right spot? No. I have just noticed that I have clicked on the wrong spot. Okay, no problem. I can just delete the wrong part and click again to mark this insulator on the right spot. Okay, so you can see the batch function did vectorize with these green lines this first part of my power line, but because I made a mistake and clicked the wrong part of the point cloud, it wasn't able to detect the rest of the points. So I can just repeat this function, and then it should do for the whole line. Yeah, great. Okay, so now you can see it really did a very well job. Here, I hope you can see the green lines are now following the points which were recorded with LiDAR. And now we have vectorized all of our power lines. Also, we can do the same for the shield wire, just by clicking here on the shield line and batch fitting shield lines. Now the software should do the same for the, yeah. Okay, so you can see I have vectorized automatically the shield wire as well as the other wires. Now, if I'm satisfied with that, I can just export this data to DXF or a shapefile. Or for example, I can, if I'm not satisfied with that results, I can delete just by clicking on these power lines. I can delete those results, and then maybe I could do it by hand. It's quite simple. You can use this single line, and then you just have to click on the first point. You have to click on the second point of your wire, and then you click on any other third point. And as you can see, the software will automatically snap the line to the wire. So it's quite easy.
Amazing.
Next thing,
really amazing.
So the next thing would be to go to the file, then to export, and I would, for example, export the power lines, vectorized lines. The last thing I would like to show you here is, for example, the analysis of the towers. So I will close all of these classes except for the tower class, just to make the view a bit simpler. Just give me a moment. Yeah. Okay. And you can also see now the wires are really well fitted here. So what I can do here is I can use in point cloud real-time condition, I can use, for example, this tool tower inclination. This allows me to create a report about the inclination of all of the towers. This is also semi-automatic tools, which requires me to select on one tower its points, and then realizes how the tower looks like. So I have to add 4 points on the top of the tower. So I will just quickly do that, just to demonstrate how easily it can be done. Oh, sorry, I think this window is a little bit too large for this screen. Okay, so I have selected 1 point. Now I can select the second point. Then I can turn around, select the third point and the fourth point on the somewhere on the top of the tower. So for example, like this. And then I do the same thing on the bottom of the tower by clicking this function. So yeah, fifth point, Now I can go to the next point. So this is just to help the software to more reliably realize how the towers look like, and based on that it will do rest of the analysis by itself. So I marked 8 points on my towers, and I can click here on this calculator icon in order for the software to calculate for this tower what is the inclination. So this is just for this one tower, but now I can click here and the software will automatically find all of the towers, and it will then compute the inclination for each and every tower. Everything that I'm showing you of especially these analysis tools, everything can be made into reports. So it is done, yes, and you can see all 4 towers now have their information about their height and also about their inclination in each direction. So I can click now here and generate report, but also what I can do is I can open already made report, which shows here each and every tower, their inclination. And what's really nice about this, you get this really nice preview how the tower looks like and how it is inclined along the axis. So that's it. And for the end, the one last thing is I showed you how you can easily vectorize your power lines. You can also use in here in vector real-time condition, you can use start and vector editing tool. You go to others and tower, and you tower editing, you can create the tower from 5 points. So this is a representation of a tower using only 5 points, but in most cases that's something that is good enough. So I just click on 4 edge points of a tower. Here, let me just do that. One moment. Okay, I can just click on the 4 points, and then I would extrude the height of the tower by clicking to the top. And now you can see I have made vectorized representation, simplified representation of the tower. So if I turn off the class, if I do that for all of the towers, I have the position of their insulators vectorized, I have the tower vectorized, and also I have vectorized the power lines. One other thing that this software can do, if you're aware of your situation on the field when you were recording your LiDAR data, you can go into the simulation condition. And now what you can do is you can do a simulation of weather conditions. This is really powerful feature. So if you can here set your parameters, for example, what was the temperature of the wire, what was the wind speed at the moment of your data collection, and you can simulate the conditions. For example, we recorded this, we collected the data, we did a survey when there was 9 degrees temperature and wind speed was 1 meter per second, and I would like to see what will happen when outside will be 35 degrees Celsius. So the software can interpolate that, and based on that you can also create reports of clash detection, and you can also based on that see all of the danger points. I think it's now it's been an hour and a half of this presentation. I would like to finish here because this software has a lot more abilities and features, but I think I have showed the most important ones. So yeah, thank you everyone. I think that would be all from my side.
Victor, we have a lot of questions. Do you have power and time to answer them?
Okay,
it was a beautiful presentation. To tell the truth, it's like a very good training, even for me as well. So yeah. I was looking for your presentation, and I was very impressed. And the first question: is it possible to colorize point cloud from photogrammetry data from P1 at the same time? What do you think?
Definitely. For this project, the client also, as I showed in the presentation, the client also has the P1 camera. And they did use it to colorize the point cloud. So they did fit. I think you can see it in this picture.
Yeah.
I will make it a bit larger, so you can see the LiDAR is just behind the P1 camera, and they took the photos. And I will show you. Maybe I can do it here. Just give me 1 second. I have here also the colorized point cloud.
While you're opening point cloud, I would say that it's possible to colorize point cloud, and it's a great advantage that we have a separate camera which can be pointed with a different angle. For example, if you need to colorize point cloud, especially need to colorize towers and some power line infrastructure, it's better to make a survey with the oblique flight. In this case, you will get much better information to colorize really colorize power line infrastructure. It's very good idea, not only to point camera to 90 degrees view, but to make an oblique flight as well. And it is easily, you can easily make it with a separate camera installed on the gimbal.
Yeah, definitely, because the LiDAR has more field of view than the camera, so it's better to have the better coverage with your oblique photographs, so photos. As you can see, so this is the same example, just colored with P1 camera photos. So you can see it is definitely possible, and it's really easy. You can do it in any photogrammetry software, so it's quite easy to do that.
We're having another question from Malik. What is the way we control the final accuracy for the LiDAR survey? Using GCP or something like that, or ICP?
So from our experience, the best way to have good accuracy is to have your GNSS base station really close to the area that you're surveying, and also to have calibrated your LiDAR. But I think, Maxim, you can maybe suggest something else to improve accuracy.
Thank you that you allow me to answer this question. What I would suggest, if you switched off sharing of your screen, I will share the screen just for several minutes.
Yeah, no problem. Here you go.
In general, it's very easy to check quality of the point cloud. How usually you can measure some GCPs in your area of your survey. In our website, you can see, you can read a lot of articles. And the last article which we placed in our blog, which we published in our blog, was how to use ground control points to check the accuracy. And we show a real example of survey which we made in Riga at the end of the year. And the client just asked us to make a test survey to choose if the LiDAR meets his requirements. And the guys from Metron companies, they measure a lot of checkpoints everywhere, in the forest, in the road, everywhere. And we made a survey with the LiDAR. We process everything and we explain it in this article. And I would like to thank you for Metron company that they provide such solution, and they measure a lot of checkpoints. Even they measure checkpoints on the power line as well. And after that, when we compare with checkpoints, we found out that accuracy was approximately 3-4 centimeters, definitely, on a border, on a road. So everywhere you have a good accuracy. Why? Because LiDAR survey is very stable. And during LiDAR survey, you don't need to use any GCPs to rectify LiDAR data. As soon as we use high precision GNSS receiver inside, IMU inside, all data set and LiDAR measurement are direct measurement. It's not a photogrammetry. And all your precision depends on IMU and GNSS receiver. And as a result, you will get a very accurate point cloud, and you don't need to use any GCP to rectify it. Just upload several GCPs to check the accuracy. Okay, do we have other questions, Alexander?
Yes, we are having a lot of. Yes, we are having a lot of
my demonstration, and with surveillance as well.
Lots and lots of questions for today. So one of the question was the comparison between the L1 from the DJI company LiDAR laser scanning with our TOPODRONE equipment. We are having an article.
Yes, we have an article about comparison, but what I would say that as soon as we use more precision and more stable IMU, high grade IMU inside, as I already said, DJI L1, it's a requirement to make a survey to stop every 100 seconds the drone and to make calibration flights. It looks like you move forward, backward, forward, backward. After that, you will fly 100 seconds. For usual speed for L1, it is just 5 meters per second. So every 500 meters, you will stop the drone and make calibration. And after that, and the accuracy, which is stated in the documents of DJI, it says that it has accuracy between 5 and 10 centimeters. It depends on low precision IMU, and it depends on a LiDAR sensor. LiDAR sensor is just solid LiDAR. It's just entry-level solution. Of course, when some companies make advertisements, they say that L1 works up to 300 meters, but it's not reality. It has less coverage of the area. For example, if we compare LiDAR sensor and Vegetation sensor, has a coverage twice higher, twice bigger in comparison with L1. Another way is noise level, IMU, and so on. So I would say that it's a very good solution. L1, it's the best solution in terms of price and easy to use. But if you need to get accurate results, if you need to check results on each step of data processing, to get stable results for all your survey, to match all your point cloud, you need something better. But of course, you can use LiDAR sensor as well. And if you install better IMU inside, it will provide better results like TOPODRONE AVS LiDAR.
We're having another question about our fixed wing solution. I have told for a customer that we are having the SuperCam solution for fixed wing and VTOL. Maybe you can add something about that.
Yeah, of course, we offer our fixed wing solution and it's quite good, and you can read about it in our blog as well. And with fixed wing drone, you will easily cover 5 square kilometers per flight of your LiDAR data. And you can install TOPODRONE LiDAR 200 on a fixed wing drone or Matrix 300 or Matrix 200, and you will cover a huge area. Due to the huge coverage of survey, it covers the distance of the corridor is just 350 meters across the flight direction. So it has a huge solution. So you can read about VTOL, and we offer with, of course, at a higher price, but it's very stable solution for flying and so on. As you can see, Victor just provided a perfect training. Really, I would say that it is a training course, not a presentation. Now you can understand in 1 hour how to process all data sets from the beginning, from mission planning to vectorization of power lines. And of course, our partners from Geocentre, they can offer you a LiDAR solution from our company, and they can provide you training, everything. So, and we have partners in US, we have partners in Israel, we have partners all over the world right now, and you can check on our website, our sellers as well, or you can contact us directly. But of course, I would suggest that Geocentre can provide very good training and very good support, even in a local area, in close countries to them as well.
Another question, what about new Agisoft MetaShape capability for detecting power lines and compatible with the LiDAR data? Are there any features in the MetaShape for transmission power lines?
Yes, of course, in MetaShape, there is a very good solution to detect power lines. But what I would suggest, if you fly over power lines with photogrammetry mission, you will need to fly with less speed. You will need to fly minimum 4 lines to make an image alignment. And data processing is depends on the quality of photos, depends on the reflection, depends on the light conditions. In this case, I would suggest for power line survey, I would suggest definitely to use both solutions, LiDAR and photogrammetry.
And
photogrammetry.
Sorry, and also if I can mention, it's quite hard to get the tower with photogrammetry, and it's almost impossible to get the ground, especially if it's below the vegetation. So this is the main difference.
Yes, from this point of view, what I would like to, I didn't say it during the presentation, but when Victor shows us how easily remove and how clean you can get terrain level, and how easy you can understand obstacles or objects which are very close, which are situated closely to power lines. It's amazing to use LiDAR. You will definitely save your time in the field. I wouldn't say that photogrammetry is not possible to use for power lines, but there are a lot of advantages, which already Victor say and I already said.
I think the last question, is there a special software like powerline or for powerline other than Civil 3D is suitable for LiDAR terrain mapping for roads, earth or tarmac? This is the question, how it is in a chat bar.
For road survey, I would say that there are a lot of software which can vectorize LiDAR data, and you can use Pixel survey software, or you can use 3D survey software, which provides you a possibility to photogrammetry process your photogrammetry data to make photogrammetry data processing. After that, you can import LiDAR data. After that, you can colorize LiDAR data from your photogrammetry data. And after that, it's possible to vectorize data. So everything is inside of one software. And you can watch our webinar together with 3D Survey company, which we made 1 month before. And it's a very interesting webinar where we show how easy you can process images together with LiDAR. And even in a very dense rain forest in Costa Rica. Okay, and I would like to say thank you for Victor, because it's the best presentation of powerline survey which I saw before.
Okay, thank you.
And I studied a lot. And of course, video recording will be available after 1 day for all our users. And we will place this video recording of this webinar in our YouTube channel. And you are welcome if you have any questions, or if you have any suggestions on the topic of our next webinar, where you are welcome to make any suggestion. And we make another one webinar for your topic as well. We will make webinar about DJI Air 2S PPK drone data processing for photogrammetry. It will come after 2 weeks. And we will definitely we will make a webinar about mission planning for photogrammetry and for LiDAR, advanced mission planning. And if you have any other suggestion, we will do it. And I would like to say thank you to Victor, because it's a great job and it's a great results and a great support for their client. They bought LiDAR, and we receive a lot of requests from clients, and they said, okay, we bought a LiDAR, and right now we need the software. Right now we need to know how to process data. Do you know how to do it? And we have a lot of issues with the LiDAR. And I would say LiDAR is stable, but you need to get the training. It's like a very necessary part. It's very stable, very accurate, and easy to process. But you need to know how to process the data, how to plan missions. In order to get these results, which Victor has showed us, you need to know a lot of issues of mission planning, to capture data properly, to process data properly, to install a base station, to use appropriate geoid file, and so on and so on and so on. And usually it takes several days to get this knowledge. So Victor, what do you say?
Yeah, I would definitely agree. It took us 3 days of training and about 2 weeks of just trying and testing. And yes, I would say we're quite well with processing now.
Okay, Victor, thank you for you. Really,
no problem. Thank you, Victor.
Great job.
Yep, thank you. Also, thank you, and thank you everyone who had been listening. So, yeah.
Thank you. Bye bye. See you again.
Bye.
Bye bye.